Before you start any sort of stoichiometric reaction or limiting reagents or percentage purities or anything like that, you need to balance your equation. So here I'm going to need to put a 2 in front of the silver nitrate and a 2 in front of the silver chloride in order to ensure that it is balanced. What do they say? How much silver chloride product will be produced, and how much usually means a mass. The amount, if I say amount, then I mean number of moles, but how much normally means a mass. And in the quiz, there were gram answers, so that seemed to make some sense. You want a mass. Will be produced if I have 100 grams of barium chloride. So I've been given a mass of barium chloride. I then need to find the molar mass of barium chloride, which is 137 plus 35.5 plus 35.5, and I land up with 208,3. Number of moles is mass over molar mass, and so I get 0,48. And then I need to set up a relationship between barium chloride and silver chloride. And that is a 1:2 relationship, so 0,48 needs to be doubled to 0,96. I then take that 0,96 up to the top here, number of moles 0,96, and molar mass of silver chloride is going to be the 108 of silver plus 35,5 of chlorine, and I land up with 143,5. Now if I want mass is equal to number of moles times molar mass, so it's 0,96 times by 143,5, and I land up with 137,76 grams. Sometimes in the decimals things go a little bit awry because periodic tables have got more or less decimal places for various molar masses. Next one over here, I need to get this equation balanced, and it's a tricky equation to balance because it's a hydrocarbon one, and you're going to have to learn how to balance these by the end of the year when we do organic chemistry. So I'm going to start teaching you how to do that now. The first thing is you take a look at you leave the oxygens till the end because there's lots of oxygen problems over here. So I'm simply going to say I need 2 carbons, and I have got 2 hydrogens already, which is great. But my problem is that at this point, I've got 5 oxygens, which is a problem because oxygen comes as an O2, and so what I'm going to have to do is I'm going to have to kind of put a 2.5 in front of that, and then I'm balanced. But that is not how we balance equations. We don't have a half in the balancing number. So I just go through the whole thing, and I'm going to write 2CH2 plus 5O2 gives me 4CO2 plus 2 H2O. So I double all the way through, and then I land up with a balanced equation. But it's quite ugly, admittedly. How many moles of carbon dioxide, so the number of moles is what I'm looking for, of carbon dioxide, could be produced from 220 grams of C2H2, which happens to be ethine, or acetylene if you prefer, but ethine's good, and 545 grams of oxygen. First thing I need to do is I need to work out the number of moles of both of those. So these were the masses, I work out the molar mass of each, and the first one is 12 plus 12 plus 1 plus 1, which is 26, and the second one is just the O2. Don't worry about the 5, and you land up with 32. I now work out my number of moles. So my number of moles is mass over molar mass, mass over molar mass, so it's 8,46 and 17,03. And the relationship between the two is a 2:5 relationship. So I go, instead of saying 2:5, I go 8,46 is to divide by 2, divide the 8,46 by 2, multiply it by 5. That's how you work with ratios. Divide by 2 times by 5, and you land up with 21,15. As you can see, 21,15 is too much to expect from this oxygen, so that does not work out. Let's try the other way around. I put the 17,03 in over here, divide it by 5, multiply by 2, and I land up with 6,81. Well, that does work. I have got enough oxygen. So my limiting reagent is I have got enough ethine. My limiting reagent is the oxygen. So I am going to use the 17,03 moles to establish my mole ratio. And I'm going to say the relationship between oxygen and carbon dioxide is a 5:4 relationship. And therefore, I don't have 5, I've got 17,03. I take 17,03, divide it by 5, times it by 4, and you land up with sorry, lost track over here, 13,62. So that's the number of moles of carbon dioxide that you can get from that sort of a ratio. The next question asks me how many grams of carbon dioxide can be produced with different masses. So I'm going to have to go through this whole process again in order to establish the number of grams. So the first one was just the number of moles, which is a little bit easier. And now we need to do the same process, but this time we're going to have to still multiply by the molar mass of carbon dioxide. So, same balanced equation. Luckily, we've already balanced it. So, it's going to be, oh, sorry, no pen yet. 2C2H2 plus 5O2 gives me 4CO2 plus 2 H2Os. And this time I have been given different masses. I got 35,5 grams and 45,9 grams, and the question mark is the mass of carbon dioxide. I have already know these molar masses. I can work out the number of moles, and I get 1,36 mass over molar mass and 1,43 mass over molar mass, and the relationship between them is 2:5. So I first check what my limiting reagent is. I go 1,36 would be, and what do I need to do? Divide by 2 times by 5, and I get 3,4. Well, 3,4 is far more than 1,43, so that's not going to work out at all. Try the other way around. I go 1,43. I divide by 5 times by 2 and end up with 0,57. That seems perfectly possible. So now I am going to use this as my limiting reagent. So again, I've got a relationship between oxygen and carbon dioxide, which is a 5:4 relationship, 1,43. Divide by 5 times by 4, and I land up at 1,14. That's my number of moles of carbon dioxide. The molar mass of carbon dioxide is 44. It's 12 plus 16 plus 16. So my molar mass is 44. I then go, what is the mass? Mass is equal to number of moles times molar mass, 1,14 times by 44. And I land up with 50,34 or 50,5 grams round about there. Now we've got another burning of hydrocarbon reaction to balance, and these, as I've said, are quite tricky to balance, so I'm going to go through it in detail again. The first thing that you need to do is balance the carbons. They're already balanced. Balance the hydrogens. Fantastic. Now we've got 4 and 4 on either side, and then we have got 2, 4 oxygens, and we just need to put a 2 there. This happens to be a particularly easy one to balance, but they can get quite tricky. All right. In the reaction, you've got 25 grams of carbon dioxide that are going to be produced. What is the minimum amount of each of the reactants that are going to be required? So I'm going to say 25 grams, the molar mass of carbon dioxide is 44. Number of moles of carbon dioxide turns out to be 0,57. I then set up my relationship with each of the reactants. Oxygen is to carbon dioxide as 2 is to 1. So I didn't have 1, I have 0,57. And therefore I have got 1,14 grams of oxygen. And that, sorry, not 1,14 grams, 1,14 moles. I take that up. My molar mass of oxygen is 32. And I can now say, what is the mass? Mass is equal to number of moles times molar mass, 1,14 times by 32. And you get 36,36 grams. Now I need to do exactly the same thing, except that this time I have to do my relationship between CH4 and carbon dioxide. So it's a 1:1 ratio. Easy. So I'm going to actually use 1,57 moles is to 0,57 moles is to 0,57 moles. Mass is equal to number of moles times molar mass. The molar mass of methane is going to be 12 plus 1 plus 1 plus 1 plus 1, which is going to be 16. So it's 0,57 multiplied by 16, and I get 9,12 grams. On to number 5. When I've got 10 grams of copper and I react it with 60 grams of silver nitrate, good news is they've already balanced this equation for me, which is really, really nice. So I've got 10 grams of the copper and I've got 60 grams of the silver nitrate. 30 grams of silver is obtained. Great. What is the percentage yield of silver? So what we need to do is we need to first establish how much silver should we have got before making that comparison. So for the moment, I'm going to put that into brackets because it's not part of my calculation. Let me work out the molar masses of everything. So it's 63,5, and silver nitrate is going to be 108 plus 14 plus 48, which is 170. Mass over molar mass, mass over molar mass, I get 0,16 and 0,35. Now I have between copper and silver, I have a 1:2 ratio, and I'm going to go 0,16 becomes 0,32. That seems to work, and if I went 0,35, I would get 0,18. That's too much. I don't have enough, so that does not work. All right, so my limiting reagent over here is going to be the 0,16 over there. Right, since my copper is my limiting reagent, I now look at a relationship between copper and silver, and it is a 1:2 relationship, so it's 0,16 is to 0,32, and I take that number of moles up to silver. But I know the molar mass of silver is equal to 108. Let's work out what the mass should be. Not what it was, but what it should have been, because I'm trying to get a percentage yield here. So it's 0,32 times by 108, and I should have got 34,56 grams of copper. But that's the absolute maximum I could have got, but I didn't get all of that. I only got 30. So what was my percentage yield? 30 out of 34,56 times by 100 is equal to 87%.